Good afternoon, everyone. Our today's topic is continuity of a function. So, before proceed to mathematical definition of continuity, we just discussed what is continuity actually. Continuous means continuous without breaking. If you can draw any curve by using any pencil and without picking the pencil up, you can if you can draw that curve, then that curve is continuous. Or in other words, if a curve which is not breaking at any point is continuous function. Continuous चलते जाना, कहीं पे भी रुकना नहीं है, कहीं पे भी ब्रेक नहीं होना, without breaking. So now the definition of continuity in mathematical form. Let fx be a real function on a subset of the real numbers, and let a be any point in the domain of f. Then function is said to be continuous if and only if limit extending to a fx exists and it is equal to f of a. Means, if you want to check any function fx is continuous at a particular point at x is equal to a or not, then you just find the values of f of a and right hand limit at x is equal to a, and left hand limit at x is equal to a. If right hand limit at x is equal to a is equal to left hand limit at x is equal to a is equal to the value of function at x is equal to a, then we can say the function is continuous at that particular point x is equal to a. Continuous function in an open interval. A function fx is called continuous in an open interval a to b if it is continuous at each and every point in the interval. Yes, it's quite simple. And continuous function is a closed interval. In a closed interval, a function fx is called continuous in the closed interval a to b if it is continuous from right at a point a, if it is continuous from left at a point b, and if it is continuous in open interval a to b. That is, in other words, you can say a function fx is said to be continuous in closed interval ab if this function is continuous at each and every point of this interval. There are some examples of continuous function here. You can draw these curve and you can check accordingly that these functions are continuous or not. For example, identity function fx is equal to x, it's continuous function, it's not breaking at any point. Constant function fx is equal to c. Any polynomial function fx is equal to a naught plus a1x plus a2x square plus dot 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 an x raised to the power n. This polynomial function is of any degree. Some trigonometry functions like sin x and cos x, some exponential functions like e raised to the power x, a raised to the power x, logarithmic functions log x, and some absolute valued functions modulus x, x plus modulus x, x minus modulus x. These are continuous functions which have to be remembered directly. There are some discontinuous functions as well. We studied about it. For example, greatest integer function fx is equal to greatest integer function of x, because the curve of this function is discontinuous everywhere. And some trigonometry functions are as well. Fx is equal to 10x, sec x. These are discontinuous functions. If you draw the graph of 10x and sec x, you can very easily judge these functions are discontinuous at x is equal to plus minus pi by 2, plus minus 3 pi by 2, and so on. Similarly, cot x and cosec x are discontinuous at x is equal to 0, plus minus pi, plus minus 2 pi, and so on. Right? Similarly, fx is equal to 1 upon x is discontinuous at x is equal to 0. There are some properties of continuous functions which are very important for solving any question of continuity. Number one, if fx and gx are two continuous functions in any domain, then fx plus gx, fx minus gx, fx multiplied with gx, and c f of x, c is any constant, will be continuous in that domain. Also, fx upon gx will also be continuous in all the points in that domain, provided the denominator gx is not equal to 0. Second property, if fx and gx are two continuous functions in their respective domains, then their composite function gof of x and fog of x are also continuous in that domain. Now there are some basic examples we can take of continuity. I repeat, a function fx is said to be continuous at particular point x is equal to a if the left hand limit at x is equal to a is equal to right hand limit at x is equal to a and the value of the function at x is equal to a equal. So we take the first example or question. Examine the continuity of the function fx is equal to x minus modulus of x upon x. X is not equal to 0 and fx is equal to 1 when x is equal to 0. And we have to check the continuity at x is equal to 0. Students, you can see x is not equal to 0 means x greater than 0 and x less than 0, right? And the value of function at x is equal to 0 is 1. And we have to check the continuity of this function at x is equal to 0 point. So first, expand or solve this modulus of x only. So by the definition of modulus function, modulus of x is equal to minus x if x less than 0 and plus x if x greater and equal than 0. If we put the value of this modulus function into this function, we will obtain the revised function fx is equal to 0 when x greater than 0, fx is equal to 2 when x less than 0 and fx is equal to 1 when x is equal to 0. So this is the fresh function now. Now we have to check the continuity at x is equal to 0. So we just find the left hand limit first by taking this function, because at x less than 0 we will use this function, at x greater than 0 we will use this function, and at x is equal to 0 we will use this function. So in other words, in left hand limit we will use this function which is 2 for x less than 0, and for right hand limit we will use this function fx is equal to 0 for x greater than 0, and at x is equal to 0 we will use the value of 1. So in left hand limit we obtained the function value 2, the right, because the function is constant function, the function is not containing any variable, that's why the left hand limit is directly 2, right hand limit is directly 0, and f of 0 is directly 1. So you can see f of 0 is not equal to left hand limit is not equal to right hand limit, therefore this function is not continuous at x is equal to 0. Next question. Show that the following function fx is not continuous at x is equal to 0, right? The function is defined fx is equal to e raised to the power 1 upon x upon 1 plus e raised to the power 1 upon x when x is not equal to 0. What it means? It means x greater than 0 and x less than 0. And at x is equal to 0, the function has 0 value. So I repeat, fx is equal to e raised to the power 1 upon x upon 1 plus e raised to the power 1 upon x when x greater than 0 and x less than 0, and fx is equal to 0 when x is equal to 0. Okay. So just check by the continuity definition. First, f of 0 is 0. Now right hand limit, solve. For right hand limit we will use this function, obviously, because this function is defined for x greater than 0 and x less than 0 in both the cases. So in right hand limit we obtained 1, and left hand limit we obtained 0. Since left hand limit is not equal to right hand limit, therefore this function is not continuous at x is equal to 0. Next version, examine the continuity of the function fx at x is equal to 0, where fx is equal to sin x upon x plus cos x when x is not equal to 0, and fx is equal to 2 when x is equal to 0. see, we can redefine this function by this fx is equal to sin x upon x plus cos x when x greater than 0, fx is equal to sin x upon x plus cos x when x less than 0, and fx is equal to 2 when x is equal to 0. Because I already told that x is not equal to 0 means x greater than 0 and x less than 0. So for x greater than 0, the function's value will be this, and for x less than 0, the function's value will be the same. But at x is equal to 0, the function's value will be 2. So f at x is equal to 0 is 2. Left hand limit h tending to 0, f of 0 minus h. We will take this function, solve, we will obtain 2. Right hand limit h tending to 0, f of 0 plus h. We obtain 2. Since left hand limit and right hand limit are equal, but left hand limit is equal to right hand limit, yes, left hand limit is equal to right hand limit, and the value of the function at that point are equal, therefore the function is continuous at x is equal to 0. These three expressions are equal, therefore the function is continuous at x is equal to 0. Next question. Find the values of a and b if the given function is continuous in 4 to 6, interval 4 to 6, where fx is equal to 3 when x less than equal to 4, ax plus b when x lies between 4 to 6, and 7 when x greater than equal than 6. So according to these limits of the independent variable, we can check the given function is continuous or not at x is equal to 4 and at x is equal to 6 according to these limits, because it is already given in the question that the given function is continuous in the closed interval 4 to 6. What it means? If the function is continuous in the closed interval 4 to 6, it means the function is continuous at x is equal to 4 and at x is equal to 6 as well. So we can check the continuity of the given function at x is equal to 4 and x is equal to 6, right? So at x is equal to 4, we find the right hand limit by taking this function. We obtain 4a plus b, right? At x is equal to 4, the function's value is 3 by taking this function, because at x is equal to 4, the value of function is 3. At x is equal to 6, if we evaluate the left hand limit, then we will use this function ax plus b, because at x less than 6, the function's value is ax plus b, 6a plus b, and at x is equal to 6, the value of the function is 7, that is 7. So by taking these four expressions 1, 2, 3 and 4, we can easily find the values of a and b, and this is our target. Because what is question? The question is find the values of a and b if it is already given that the function is continuous in the closed interval 4 to 6. So it is already given that the function is continuous at x is equal to 4 and at x is equal to 6. So we just take the concept of the continuity at x is equal to 4 and x is equal to 6 and find the values of a and b. This is it. Thank you very much.